I welcome you all for the last day of the FDP, session 2. In this, we are going to see the blockchain databases. The current speaker is Dr. Parmeet Kaur, madam. Dr. Parmeet Kaur is an associate professor in the Department of CSE and IT of JP Institute of Information Technology, Noida. She has an academic experience over 20 years. She received PhD Computer Science and Engineering from NIT Kurukshetra, MTech CSE from Kurukshetra University, BE Honors Computer Science and Engineering from PEC Chandigarh. Her research interests include distributed systems, IoT, cloud and edge computing, blockchain and big data data systems. She has published more than 60 papers in various reputed indexed journals, peer-reviewed conferences, and book chapters. 2 students have been awarded PhD under her supervision, and 3 students are pursuing doctoral research in the domain of distributed computing, big data, and federated learning. I am very happy that Parmeet Madam accepted to give a talk on blockchain databases. Sure that this talk will help us a lot in taking up further research or further projects in our academics and research. Madam, please start the presentation.
Yeah. Thank you, Dr. Raghu. Should I start presenting? Yeah. Yeah. Yeah, so please confirm if the slideshow is visible.
Yes, please.
It is, yeah. Yeah, good morning, everyone. Thank you for having me in this FTP. It is the last day, last session, but I hope the simplicity and maybe slight novelty of the theme will keep you interested in this. So the topic for today is blockchain databases. So the agenda that I have selected for this particular 1 hour talk is, let's compare first of all blockchain vis-a-vis the databases. Then if blockchain and databases exist independently, then what is the need of having blockchain databases? And if now they are available, what are the features that they are coming with? And I'll give a case study of a blockchain database, which is actually a database as a service. So out of the various solutions that are available, I found this to be a simple to use and having all the features of blockchain databases. So I'll give a short demo of ProvenDB. So ProvenDB is a combination of a blockchain with a database, which is a true blockchain database. So I'll give you a short demo so that those of you interested can then continue working on this ProvenDB. So let us start with a few initial questions that come to the mind once we talk of databases as well as blockchains. So we are all aware now of what is blockchain. We've had this FTP for the complete week. So it is kind of a ledger which is storing information about transactions, and the main features that are the immutability and how the data is not going to change, and the verification of data is built into the system. Then if I talk of databases, so databases are also any kind of data structures, so a very crude definition which can be used to store information. So the question that arises, or the thought that comes to the mind, is that are databases blockchains, or the vice versa? Are blockchains not databases? Why do we need to talk of blockchain databases? Because blockchains are already storing information. They have been used to, developed to store information about transactions. So are they actually not databases themselves? And then if I'm saying that there is a concept of blockchain database, and what makes a database a blockchain database? So these are some of the questions that we'd like to find answers to. So if I compare a bit in detail what is a blockchain and what is a database. So blockchain, I am sure each of these has been covered in detail. But if I talk of comparison with database, so in a database, though all the databases these days have security built into them, but they cannot be compared to a blockchain in terms of the data integrity. So even though people have theoretically said that there is a 51% rule that blockchains can also be tampered with, but still it is virtually impossible to change the data. But if I talk of databases, then we are not so sure. Okay, so a malicious user can potentially alter data if you are not taking the necessary measures related to data integrity or data security. Then next coming to then the transactions. So if I talk of transactions that are being put into the blockchain, so we know that the data can only be read or added to the blockchain. So they are a kind of append-only system. So once you have added to them, so you don't need to change them. You don't have to change them. You cannot change them, but you can read the data, and that data is available to all the users of the blockchain. But if you compare that with a database system, then the databases are made not only to read or add to the database, but you also need querying abilities, or you need modification abilities, you need deletion abilities, which are not available with blockchain. So you will not be able to update or delete something from the blockchain, the theoretical blockchain if I talk of. So that facility is available with databases. Similarly, if I talk of querying performance coming from the database community, so if I talk of blockchain, so as the blockchain's data the blockchain data increases, so the heavier the blockchain gets, the more difficult it is to difficult in the sense that it will take time. So the performance will come down. So it is going to take more time to add to the blockchain as well as to read from the blockchain. But databases, so for coming from relational to the NoSQL systems to systems like Redis, which are giving you thousands of read transactions within milliseconds. So you are used to a fast access to the data, which you don't get from the blockchain. And if we talk of the structure, then obviously blockchains are completely decentralized, but databases will normally have some kind of central administrator, even if it is a distributed database. So there will be some kind of administrator who will be controlling where the data goes, who gets the permissions, and so on. So the idea of putting these points here is that even though they are overlapping in terms of having storage of for data, but they are exactly not the same. So I can easily say that blockchains are databases. Actually, they are decentralized or distributed databases, but databases, they are not always blockchain databases. So if I take blockchain again as a database, so I don't need a separate paradigm. Why not take blockchain as a database? Then what is the problem, or what is the challenges, that as you talk of the size of the blockchain or the size of the data that is going into the blockchain, then the querying performance starts reducing. So the speed of read operations from a blockchain will not match anytime the speed of read operations from the of the any database, and of especially the databases that we are using these days, the new age NoSQL or NoSQL systems, they are actually really fast. So we are getting some positives obviously from the blockchain. We have seen so many positives of the blockchain, and they have a special niche requirement. But again, to use them as databases will not give you the same performance because of these features which databases only give you of updation, deletion. So if you're looking for a database, then blockchain will not help you. So that is why we are motivated to go for blockchain databases if your requirement is not only appending and storing the data, but also retrieving the data or updating the data or modifying the data. So there is that is where blockchain databases come into play, because they are going to combine the best of both. So we are going to get blockchain features also, and we are going to get database features also. So this on your screen now is about from DB's structure only. So here we see that you as a user are inserting, updating, deleting, reading the data through DB. And this is DB is a blockchain database which is going to provide you and manage for you both the database as well as the blockchain features. So, what are the features that we are going to get into, get from a blockchain database, which we may not be getting from simply a database? So, we are going to get immutable data. So, immutable data in this blockchain databases word means that data is not destroyed when you update or delete. So if I take an example of any database system, maybe MySQL or Mongo or any other. So if I'm updating or deleting a data, so now what will happen is how the immutability is achieved, that the data is not destroyed, it is marked. So we'll see in Proven DB, and even in Cassandra, and even in Cassandra, a tombstone marker is kept. So that means this is a previous data, and this is what is the current data. So old versions will remain available indefinitely. So the older versions of the data, that means the data that you have said is now deleted, you do not want, or you have updated, but still they will remain. Why do they remain? Because you are also trying to get the blockchain feature out of it. That means you want to maintain the history of the data, that how this data has evolved. So multiple versions of the database data are maintained. So you can always move back in time. So wherever you are, that is your current version, but the previous versions are also maintained, and you have just to specify the time or the version number, and you can move back to that previous state of the database. Then the other feature that is coming from the blockchain word into the databases word is the blockchain proofs. So you want versions, the complete database version, that means one instance of the database, or the individual data records or the documents, their proofs should be maintained. So that blockchain proofs will help you maintain or prove that such and such kind of data existed on my system. It was owned by so and now this is the data. This has not been tampered with. So the complete history of the data item can be retrieved, and who will prove that this history is correct? The blockchain proof will prove that this data is was initiated into the system by this user or has seen these many changes, and this is the current version. So best of both. So if I talk of three things here, blockchain, the distributed databases that already exist, and then this new paradigm. So new in the sense that it has been there only for around, I think, 5 to 7 years, not more than that. And most of the systems are still evolving. They are giving you some community versions that you can try. So some of the features we are getting from the blockchains: immutability, no central authority. So you have made it a decentralized system. You can save your assets over a network, and some of them we are getting from the distributed databases world. So we want high throughput. So with these features, we also want these capabilities. My throughput should be high. That means how many transactions I'm able to process in a time unit. The latency should be low, and I should also have all kinds of query capabilities, because coming from the databases, we want all kinds of querying abilities should be there. So the blockchain databases, so this is a table from BigchainDB, that is another example. They claim to have all of these features in one solution. So some of the examples of these are Proven DB that we're going to discuss today in some detail. BigChain DB, that is another one. Chainify DB. So all these are those which have some kind of initially. So Proven DB is a database as service. So as any other cloud service, it is free till one service. But if you have to have it at a greater scale, then you have to pay for it. Similarly, BigChain DB is also open source. Chainify, I'm not sure, but Amazon Quantum Ledger Database again is a Amazon service. Similarly, there is an Ledger SQL from Azure also that I was checking out, because for this Quantum Ledger database and for Azure solution, both of them have the similar to SQL kind of query language. So your learning curve decreases. BigchainDB and ProvenDB both are MongoDB based. So you're going to run MongoDB commands here, but this Amazon solution as well as the Azure solution, they are both SQL based. So just to give you an idea and overview before we go deeper into this. So this is Amazon Quantum Ledger database. So you can see the word is coming database as well as the ledger from the blockchain word. So your application data, you have to put it to the Amazon's quantum ledger database. And what is this QLDB doing? It is storing your current state as well as it is maintaining a journal. Journal is the like the log, which is an immutable journal. So your current state will keep changing, but this journal is used to keep a record of what all operations have been done on the data. So because of this current state as well as the history, you can access your complete history or changes to your data. And this journal can be used to give a cryptographic verification of your database. So what they are doing is that for the user, the interface is only this QLDB, which is accessible using some drivers or by using SQL type. PartyQL is the language, which is very similar to SQL. But on the backend, they are maintaining these two kinds of data structures so that you are able to access your data also and you are able to verify your data also. So just an overview, otherwise we'll discuss in terms of proven DB only. So use cases, we have enough of use cases, and I'm sure there has been a number of applications discussed. So the use cases remain the same. The only thing is that these are all use cases where you also like to query, where maybe you will also like to update the data. So if some of these use cases involve those kind of updations or deletions or querying, which is more complex, then you can use a blockchain database for that. So what is the architecture before going into the usage of this? The architecture, how are they implementing? Some idea we already have seen from 12DB. So what is done is that most of your concepts of blockchain will come into it because we have somehow to maintain the proof of the data which is in the database. So there are easier to take an existing database. So most of them are taking an existing database. So ProvenDB and BigchainDB, both of them are taking Mongo, and the Amazon's and Azure solutions, they are built on a MySQL type of relational database. So obviously they have their own proprietary technologies. So most of these systems are taking an existing databases and adding a blockchain feature. So rather than trying to use blockchain as a database, what is being done is that we are taking existing databases and then trying to add blockchain features on that. So for blockchain features, two type of layers are in general used. So obviously they will vary from one to the other. So the first layer will utilize some kind of distributed consensus protocol. So because we want the nodes to agree on the data before it is entered. So there is some kind of distributed consensus protocol. And the second layer is using a proof of work based blockchain. So some of them are using their own blockchains, but ProvenDB is using the Bitcoin blockchain for storing their proof of works. So both of these concepts are used. There is some kind of anchoring mechanism that will have communication between these two layers so that a chain of evidence is created. So you will see that you can submit proofs or you can ask for proofs of your data. You can verify your proofs of data because ultimately the proofs are being stored on some kind of blockchain. So there are various types of architecture depending on two main factors here. One is what is the type of deployment and what is the type of, so second is what is the type of data. So type of deployment here means are we looking for enterprise-wide only, or are we looking for a consortium type deployment? So if it is an enterprise kind of deployment, that means within this blockchain database, we are trying to get something which is centralized, so available only to a few nodes only. But consortium type deployment means we are looking for completely decentralized systems. So the level of deployment will tell you how close it is to a blockchain. Then the data can also be operational as well as non-operational. So operational means that the users can directly access the data. So any user can come and access the data. For example, the cryptocurrencies, if you're storing on a blockchain database. And non-operational means we are going through some kind of intermediary level. So we are maintaining some kind of administration there, not providing the direct link of the data to the user. So if I talk of centralized with operational data, so this is the most easier to implement, but all of these types, I would like you to see the blockchain database. So there is a core database here, which is now centralized. And on top of that, we are providing a blockchain database. So if I'm going for centralized with operational data, that means the database is stored in a centralized form only. So it is further from a blockchain concept. But you are trying, why is we are calling it a blockchain? Because we are maintaining the versions and the proofs of the database. And there is some kind of admin control on this database. So maybe it is within an enterprise only. So it is counterintuitive if you talk of a blockchain, but as compared to a core database, it is still giving you some advantages, which are some kind of proofs or verification of data or immutability of the data. So though it is not very close to being a blockchain kind of system, but it is better than having a core database in terms of immutability. And the clients are accessing directly this data, so that is why the data is being called the operational data. Okay, far from the blockchain. So as we move from centralized to decentralized, so we are moving closer to the blockchain concept as compared to the database. So this again is a centralized type of architecture. So again, there is a core database. On top of that, we are building a blockchain database, but under the control of some admin. And now the data type here is non-operational. So that means the client is going through some kind of intermediary database layer before and cannot directly come and access this database. So there is some kind of a view of data which is available to the client, and the client does not have a direct access to the core database or the blockchain database. So as you move the client away from the core database, that means we are increasing the security of the system. Then the third kind of system, now we're moving to the decentralized kind of deployment. So again, there is a core database. On top of that, we are maintaining a layers for blockchain. And now they are distributed amongst multiple nodes. So now the decentralization has come into play. Now some clients are accessing from some location or some other node. There is some other node, and this is the third one. So the control or the admin is now limited to a part of the chain, not the complete chain. So you may have some people, so each one of them has a different use case. So this for this you may need to have an increased privacy. So the earlier one was more secure because it was centralized. So here you will have to build in more privacy controls there. Then the fourth one is the complete decentralization along with non-operational data. So you will have limited clients accessing the database because you are going through intermediary layer. It is not the directly operational data, and plus it is a decentralized scenario. So these are the various types of deployments that are coming for the same concept of blockchain database. So the next part of the this lecture is now going to be based around proven DB. So proven DB is one example of a blockchain database, and there is no saying that this is the best or this is the only. This is one which I found simple to use. you can easily integrate with your applications. So you have drivers for Python, even for Java or other languages also, even for Go. So you can build applications, integrate them with this blockchain database. So just like you integrate with any kind of database at the backend, so you can integrate your applications with this blockchain database. And plus today, the demo that I'll be giving, I'll be using a MongoDB shell to directly issue the commands to this ProvenDB. So what is this ProvenDB? ProvenDB is a blockchain service actually. So this is a database as a service uh, which is available, and it is integrating two things because it is a blockchain database. So for the blockchain, it is using the Bitcoin's blockchain, and for the database, it is using MongoDB. And since it is a cloud-based service, so it is using actually MongoDB Atlas. So what is MongoDB Atlas? MongoDB, we know, is a document-based database, which is a NoSQL database. So MongoDB Atlas is the offering of MongoDB, which is available as a service. So you can set up your clusters, you can say how much storage you require. So till a particular amount of storage, it is free to use. After that, you have to pay per use. So this Proven DB will be using this MongoDB Atlas at the backend. So the users are interacting with Proven DB. Proven DB is doing two things. It is like a front end to MongoDB. So it will be storing your data in MongoDB Atlas. And for the proofs and of your data, it is going to use the Bitcoin blockchain. So the proofs will go into the blockchain and the data will go into the MongoDB Atlas. So most of the functionality of MongoDB is available with ProvenDB. So you're getting the database kind of functionality. So the same querying performance, the same latency, everything. Some of the things are not available, some of the features which are mainly related to the distribution. So sharding is distribution of data because you are accessing ProvenDB, you are not directly accessing MongoDB. So the sharding or application commands are not available. The rest of the commands you can use from MongoDB in this ProvenDB. And this blockchain will be used for storing the proofs of your data. So what is ProvenDB giving us? So this is a MongoDB compatible service. So we are getting the normal throughput, latency, all the CRUD operations. That means you can create, read, update, delete the data, which is different from the blockchain. So that is why it says that it is bridging the gap between blockchains and the databases. So everything that we have discussed with respect to blockchain databases, the immutability of the data, that is provided by using data versions. Because there are versions, you can get a point in time history. That means I can point to some instant in the history and say I want the version of the data at that point. So that gives you the feel of a blockchain. The provenance, data provenance is maintained. That means you can retrieve the complete history of the data. And you can also verify that the data that you have entered into the system has not been tampered with, because you can verify the proofs that the data has not been altered at any time in the past. So all these features we are getting from ProvenDB. So we'll talk very briefly about each of these features, so that you can understand how a blockchain database is actually working. So ProvenDB, now when I say it is MongoDB compatible, it is giving the normal throughput, latency, normal operations. That means I want to enter my data into the database and I want it to perform just like a database. Otherwise, I could go directly for a blockchain. If I don't want the update or the delete or the querying performance, and there is no need to go into this blockchain database, then you can simply use a blockchain. And secondly, the programming part of it. So you don't have to do a complex programming, because if you are comfortable with the databases, then this is the go-to thing for me. So it is giving you the performance or the features of the database, but actually it is an append only database. So it is like an abstraction. So the user feels that I have updated the data, I have deleted the data. So feels means if I enter the data and I retrieve, I'll get the one which I'm expecting. But at the back end, what is happening is that each data, once you change the data, a new version of the database is created. So once I show you the commands, you will get a feel of it, how the versions are changing. So ProvenDB then differentiates between the current version and any previous version by creating tombstone markers. So tombstone is what is there on the graves. So this data has been deleted from the view. So the data is given a flag or a marker that this is previous data, or this data belongs to this version of data, and the current version of the data remains as such. That means the current view is differentiated or distinguished from the previous views. Anytime you create or enter new data or update a previous data, so you are creating a new version of the database. Plus, the previous versions, if you think you'll not be able to manage, or you have created too many versions of the database, or the earlier versions are not required, you don't want them to stay in the, so it is up to the user. In that case, ProvenDB allows for version compaction. So compaction is same as we know. So compaction means that the previous versions can be deleted. So it is up to you. So if you don't say that delete my previous versions, the previous versions will remain infinitely. Every version is created on top of the previous version. So it is like a serializable consistent view. So if you have created a new version, so it depends upon the previous version. So the first version, so if you make changes, it becomes the second version of the database. That is your current. You can change your version to a previous version. I don't want to see the current version, I want to see the previous version. You can come back to the current version. So you can move between the versions. Then, talking of proofs. So version means one instance of the data in the database, how the database looks presently. So what is a proof in ProvenDB? The representation of a particular version that is hashed and that is anchored or pinned to a public blockchain. So in this case, as I just mentioned, it is a Bitcoin blockchain which they are using currently. So this Bitcoin blockchain is used to give cryptographic proofs of the data. Okay, so how do you know that this data existed in the past? So you need to have those proofs. So the proofs are kept anchored to the public blockchain. So the same concepts, the hash values are posted to the blockchain. So we'll see that once we create a proof, it is takes some time for that proof to go and get pinned to the proofs. So I just mentioned that the proofs are your state of the database at a time, which is hashed and it is stored to the public blockchain. So ProvenDB is using the Bitcoin blockchain, but the commercial providers like the Amazon and Azure, they are using their own private blockchains to store that. So these proofs will help us to verify in the future that this data at this time when it was the proof was generated, till from that time till the present time it has not been altered. So the same thing also exists in the blockchains. So there is no need to elaborate on that. But what is happening here is that ProvenDB, what it is to using is it is based on MongoDB. So MongoDB, like in a relational database, you have a table and there you have records. So MongoDB, you have instead of records, you call them documents, and they are stored within collections. So collection corresponds to a table, and the documents they correspond to the records within that collection. So what they have done for efficiency is that thousands of documents that are within various collections, they are proven with a single blockchain hash using the concept of Merkle trees. So Merkle trees are giving actually are storing the aggregated proofs. So I'll show you this Merkle tree path. So if you see here, these are the various documents in the database. Each of these is hashed for the proof, and then these proofs are further hashed until you get a final root hash, and this root hash is then placed on the blockchain. So now you can prove the complete collection of data using this root hash. And if you need to give the proof of a particular document, then you will only need to specify the Merkle path. And you get this when you generate the proof of the document. So what is a document proof? You store the Merkle path which connects the individual document with this version proof. So this is on the left is your complete data. So each of these documents is individually hashed, but these hashed are further combined and hashed to get one aggregated proof which is placed on the blockchain. So this hash, the root hash, will actually prove the complete version of the database, and the path to one of these documents will prove that particular document. So these aggregated proofs are used for increasing the speed or the performance of the system. But even then, once I say submit the proof, it is not immediately pinned to the blockchain because the blockchain will take its time. So after at least half an hour or after at least 20 minutes, depending on what is the size of the data. If the size of data is large, it may take even up to 1 hour. You will again see, then you will get the proof of your database that yes, it has been added to the blockchain. So it takes time to put it in the blockchain, but you have submitted the proof. That means whatever was a version of the database at a particular time when you generated the proof, that is now immutable because it will ultimately be put into the blockchain and you will get the proof which you can verify anytime later. So for ProvenDB, they use the chain point protocol to connect the multiple proofs. So this I just mentioned that once you start a proof, it is in the pending status. If you check it a few minutes later, it is submitted, and then finally it moves to the valid or the confirmed state. So once it is valid, that means now your data version is approved using the blockchain, the Bitcoin blockchain. Now, once we talk of blockchains, another concern that comes is that once the data is in the blockchain, the data remains there forever because you don't have a way of deleting it. So now talking of privacy and the GDPR's right to be forgotten. So that has now been because in this blockchain database, you are able to do some kind of updations, deletions, and so on. So there is a forget command. So forget command will be it will help you remove all information from the documents, but you have to be careful that because the primary key has been used in generating that hash and the proof of the document, that is not deleted, but all non-primary key information you can delete using the forget command. So that immutability is there till you want it. But if you want that my data should be removed from the blockchain, then you can use this forget command. But keeping in mind that only the non-primary key information will be deleted. So if you want to implement GDPR for your organization or for your own data, then you don't have to put your personal information in the primary key. So that information which you think you will want to remove from the blockchain at any point in time in future, that should not be a part of the primary key. The rest of the things will be deleted. And locking and concurrency features. So I'll not be giving a demo on this, but yes, locking and concurrency features of databases, they are also available in ProvenDB. And when the proof is being generated at that time, or the Merkle tree construction is taking place at that time, we may get this, may not be allowed to update, delete, because at that time the documents are locked by ProvenDB. So we can use ProvenDB to prove that we have created some content in the past, that the data has not been tampered with, provenance of data, that means the date of the document, the exact history of the data. Right? So I'll move again. I'll have to change my network because of some firewall issues. I'm not able to connect from this network to ProvenDB. So I'll just give me a second. I'll again change my network. So now there are two things that need to be done if you have to use ProvenDB. One thing is that we have to create just give me a second, please. One is the link I'm shared in the slides also. So it is just provendb.com. We have to log into ProvenDB. So if I just maybe log in again, so I've just the first page of ProvenDB tells you to log in. You can log in with your Gmail account, and you
Madam,
come to
you may
this.
place the URL in the chat box so that they
Yeah,
will check.
sure, sure. Yeah, right. Actually, yeah, you can use if you want. I've created a document also. So because I've already created a service, so that is why this screen is coming. Otherwise, you'll get something like this. Plus sign comes, which is to create a new service. So the first service, as I told you, is free. But once I create a second service, then it starts billing me. So I'm not going to create a second service, but you can just give it any name that you want. Okay, so if I give it some name, then you have to authenticate. That means you have to give it a username, password. So the thing to note here is that you have to remember the username, password that you give here, right? So your username and password with which you are logging in, that you have to keep a note of, because otherwise you will not be able to connect to this service, right? In the plan selection, you simply have to select the free plan here. So that is what is happening here, right? So once you create this service, so only thing you need to say is your username, password, and a name to the service. So for me, I've created this BD the name of the service. You can see it is free. So once you create that, it will take around 5 minutes, less than 5 minutes. But after that, you will get this URI. So this URI is going to be used to connect to ProvenDB. So you can use this URI from a shell like I'm going to use now. Otherwise, you can, if you're writing an application, so you just have to download the ProvenDB's driver, and where you give normally the local host and the port name, instead of that, you'll have to give this URI. So this URI is actually giving you your service name plus your username plus your password. So you have to replace this username with your own username, the service password with your own password. That is it. So this remembering of this username password is important here. So if you are creating now, it will take around 3 to 4 minutes to create this service. Once created, then it is always on. I think they have a 30 days trial for one service. After that, it will not be available. So the first thing is creating this service in ProvenDB, because this is a database as a service. So this is uh, giving you this service creation. So you can see there is a query playground here. So playground is where you can, they have already given some commands that you can try out. Just run them, execute them, and play around with the ProvenDB. Now, the second thing that I'm going to do now is that I have a MongoDB shell with me. So that shell that I have downloaded now is this one. I'll just see if I can, for my system. So those of you who have worked with MongoDB, working with MongoDB requires a MongoDB server and a client to connect. So the server now is replaced with your ProvenDB service, but you need a client where you can run your commands. Okay, so this is the one that I have downloaded and which I'm going to show here. So because of these network issues, I've already entered the commands today morning only so that you can see here. So once I run my MongoDB shell, so running means just double clicking on the shell. I'll show you that also. So this is the software that I have downloaded. Mongo shell, bin, and here is the application. So I've just double clicked on this Mongo shell, and this kind of window will come. So the window says please enter a MongoDB connection string. So as I just mentioned, this is the Mongo client, so it is looking for a Mongo server. So if you have installed MongoDB locally, then we normally give the local host and the port number. But because now I'm going to use ProvenDB to connect to, so what I'm going to use here is this ProvenDB URI. So the URI that it is giving me here. Okay, so I've just copied this URI here. Okay, so just clicking on this copies it to the clipboard. Now what I've done here is, if you see here, instead of the username, the words username, I put my username. So my username was Parmeet. The rest of the thing remains the same. I didn't enter my password, otherwise you would have entered the password here itself and clicked enter. Once you click enter, it will ask you for the password. So this is the same password that you created, made while creating the service. So once this password is entered, so it will connect to this service, the ProvenDB service, using MongoDB. So they are using MongoDB 4.2, and the Mongo shell is the one that I have used. So now this is the terminal that I get on connecting. Okay, so as simple as that. So because this is my service name, if you have created some other, obviously you'll create some other name service. So whatever is the name of the service, that will come here followed by the greater than sign. Now at this point, you can enter any of your MongoDB commands, because you are using the ProvenDB service. So ProvenDB service is using Mongo Atlas in the backend. So any of the MongoDB commands can be used here. So I have created a collection which is db.restaurant. So this is a simple MongoDB command which is inserting data into a collection. So the name of the collection is restaurant. It has two fields. I put location, name, and the third one is the rating. So this is like one record. The attribute name is location, the attribute name is name, the third attribute name is rating, and I've put it into a collection which is corresponding to a table. So जैसे table है MySQL में, similarly you have collections here. So the name of the collection is restaurant. So any MongoDB insertion, deletion, updation now you can do at this command because it's a MongoDB shell. So some of the commands that you will see here, they are the simple MongoDB commands, but I'll walk through this. I'm not sure how clear this is. So what I can do is, I'll share the document for this. Or is it visible, sir? As you tell me. If you want, I can share a document with you,
Okay.
which has this complete thing so that everyone can go through it.
You may explain that, madam. Afterwards,
Okay, I'll just explain it. Yeah. So I'll quickly explain it. Later on, we can see. So some of the commands, as I just said, are simple MongoDB commands, and the other commands are now the additional commands that are coming because of the blockchain features. So for example, the first command here that I'm running is I'm trying to get the version of the current database, okay? Because I have used this service previously also. So I'm trying to see which is the version I am there in at presently. So the command here is get version command. So all this documentation is available on ProvenDB site. So you can get all these commands from there. I have also taken from there only. So get version command will return what is the current version of the system of this particular database. So you can see here that the version is set to current. So this is a current version and they are giving it numbers. So here this is the 7th version of the database because I have already before this session, before that also I have entered into the same collection, same database. So this is the 7th version and this is the current version here. So whatever I am inserting now, so I've inserted one document, the second document, then I'm running some other commands of MongoDB. All these are going into the MongoDB Atlas using the interface of ProvenDB. So if I try to print all the documents, so I use the MongoDB command find. So it will give me all the documents in my collection. Now I have saved. What I'm trying to do is I'm trying to create a new version of the database next. So what I do is that I get the current version and I save it in a variable version 1, because later on I might want to come back to this version. So version means what is the instance of database currently. So I save the name of the version or the number of the version in a variable version 1, and then I make further changes to the this collection. So I've inserted another record here. Now after that, so version here has been saved, and now what I'm doing is now I'm setting the version as version 1. What is version 1? The version 1 was the version till this point. After that I inserted some record. So obviously once you update your database, your version is changed. Version means at one point in time. So now I've set again that set version to version 1, and then at this point here. Sorry. So I've set the version to version 1 here. So one thing that we now see is that if I change my data to a previous version, my database to a previous version, so that previous version should be immutable. You should not be able to change to the previous version. So if I change my database to a previous version and then I try to make some changes in that database. So I try to make a change in the database. So it will not allow me to make a change in the previous database. So what I've effectively done is I made a version, I saved that version number, made some more changes to the database so that the version is changed. Then I went back to the previous version and tried to change it. So if I make change in the previous version or try to make a change in the previous one, the system will not allow me to make a change in this. So what I have to do is, if I want to make a change, I can change only in the current version. So I set it back to the current version, and once then after setting it back to the current version, if I try to insert, at that time the insertion is allowed. So this is about the versioning of the database, how it is done. After that, another thing that I'd like to show you quickly, because I think we're running short in time. The other thing that I want to do is I want to submit a proof of my database, because I'm using ProvenDB just like a database. If I want to use it as a blockchain database, then I need to have some proofs of my database. So if I need to set a proof or submit a proof to the blockchain, then I use this command, simply submit proof, and what I'm giving here is the number of the version. Okay, what is the current version or what version number for which I want to proof on the database. So now if I submit the proof is submitted, but if you see here, the status is pending. Okay, so you get a proof ID, you get the date time, you get the version, but the status is pending. Okay, so status is pending means that your proof has been submitted, but it is not still anchored to the blockchain. So that is why the status is pending. Now, once after some time, so there has been a time gap here. Yeah. So there is this collection of ProvenDB, which is again available in the documentation, ProvenDB version proofs, that how many proofs exist. So I've simply printed that collection, that table of records of versions. So I see that there are two proofs existing with me. Okay, so this within the first curly bracket is the first document, within the second curly bracket, that's the second document. A previous proof that I had created, that status is showing as valid because some time has elapsed. So whatever was my sixth version of the database, you can see here, for that the proof has been entered into the blockchain, status is valid. But this current one, jiska abhi I have submitted the proof, the version is 9, the status is still pending. That means it has not been entered, it has not been confirmed yet. But if I run it again, okay, so after some time gap, I again gave this command, the same command as above. Now if you see version 9, the status is valid. So this means that my database instance, the version of database 9, that has also been now entered into the blockchain. So now the status is valid. So just like the version 6 was valid, so now the version 9 is also I'm having a proof. So I created various versions of the database, but what are there on the blockchain are those for which the status is valid once I try to print the proofs. So apart from these commands, then once you have created a proof, so I'll show you some more commands there. Maybe we can try it later. Um, I'm sorry, just a second. Yeah. So after that, if you want to verify the proof of any database collection, so these are the IDs which are given by MongoDB. So there is no need to worry about these long IDs. These are primary keys which are generated by MongoDB itself. So you can say that I want to verify the proof. If I want to get the proof, I want to see the proof, then you can say the get proof command. Apart from that, if you see MongoDB, so instead of going just through the MongoDB, you can also use this ProvenDB's dashboard to import directly data here. So if you have any document for which you need to create a proof, so you can add that file directly here. Afterwards, for after again some time, यहाँ पर अगर if you have entered the document, on right side of it you will see the proof of the document. So the complete documentation is also available with ProvenDB, and then you can use this query playground again to run the various commands. Right. So coming back to our slide, so I'll just try to wrap up now. So blockchain is a database, but database is different from blockchain. So blockchain-based database then will provide you the functionalities and features of traditional databases along with the blockchain features. So you get tamper-resistant and immutable database along with the performance of databases. So these are some documents that I actually refer to. So ProvenDB's all documents which I have used in these slides, they are available at this link. The architecture part of databases are taken from the first one, and you can also try out another very interesting blockchain database, which is BigchainDB. So that is also MongoDB based, but is more closer to blockchains as compared to ProvenDB's interface. So thank you, and thanks for this. I'm sorry for the interruptions because of my network issue. Yes, Raghu sir.
Thank you, madam. Very nice presentation. And
Thank you so much.
many concepts were easily understood.
Okay. Thank you.
Participants, if you have any doubt, you please ask.
Sure.
Participants, you are requested to turn on your video so that you can have a click. Participants. Okay.
Yeah.
Madam, actually, this there is a Web3.js library will be there.
Okay.
There is no need of actually. It's not a driver actually. It's only library.
Okay.
So library has the facility to connect with the backend that is blockchain. But
Okay.
here driver means every client has to install their own driver and has to connect.
Right. Right.
So
So
there is
for
no
every
option.
application, you'll have to put yes.
Okay. For every whenever during the
Right.
deployment process, on every
Right.
client we need to install this driver.
Yeah. So maybe you can use the other thing.
So sometimes if compatibility issues come, then you can stop.
Right.
But if the library is there, then it will be irrespective of
Better to use.
configuration we can connect.
Okay. Yeah.
Okay,
Mhm.
participants, if you have any doubt, you may ask because this is
Yeah.
a very
Otherwise,
nice area that is blockchain databases.
okay. Thank you so much for having me. Yeah. Thank you.
Thank you, madam. Really, we had a wonderful session.
Thank you so
Thank you,
much.
madam.